Welcome back, Michael Wickerson here, plugging through the Vectors tab in Grasshopper for Rhino 3D. Just move my face over here a little bit, and we are going to be spending a section on the Vector tab. What's in there and what you can do with it. Now the trick with vectors is you'll need a vector display, which is tucked into the display. You'll realize that over here you're going to have a vector display. I prefer the vector display the red ones instead of the green ones. I find they're enough, and I don't like the default width on the arrows for the vectors from the extended version. So I'm going to be using that one. So what have I done here? Basically, I've created points, a point from these parametric sliders, and the vector itself does not come up under a display tool. Let me just make the habit of ungrouping this. You're not able to go on here and preview on and see it change because you can't view a vector. The only way to view a vector is to pull it in, that vector, into something like this, and then all of a sudden you can see that vector is made visualized right there. So I'm going to just change that back, and of course I jumped out. Let's go back in here and change that back. And I think that's where it was. Yeah, right there. And then I have the Y component of what's driving that, taking the point and breaking that down into its point attributes. So here's my point. The vector to point, you can default to the point 0, 0 to start everything. And I'm going to go from point A to the point that I've constructed. And that will produce a vector that then can be visualized as from this point up till there. I then have a unit vector, which will reduce it to 1 unit. And I also have the ability to have a factor on x units to have a nice little vector that runs out in the x direction, I believe the y direction, and the z direction. And of course the z direction, I wanted to have a little bit of amplification factor to make that larger and smaller. And I'm snapping to an integer value here, so it's not running smoothly. But definitely vectors, you want to learn how to visualize them. Try creating vectors like points. Be sure to visualize them. Nice and easy, right? So let's take that. Let's jump out of preview. Actually, I didn't mean to take preview off. Let's put preview on, but let's group that and then say let's regroup that. Of course, I forgot these two. Let's add to group, and then let's visualize that as a color blue. All right, so let's keep creeping down here. The cross product and dot product are much more vector analysis and tools you need for vector maths. And if that's not something familiar, you might want to go online. Some of the formulas for it get a little tricky, and it's not something I carry around with me. I know that they're available in books. But let's take a look at what's happening here as I get rid of all these visualizations. I have a unit vector that's here on any level. I'm going to take this off, ungroup while I'm looking at it, preview on. Once again, it's a vector. It's not going to come up. You're not going to see anything. But those vectors are coming out as a list of 3 different vectors, 3, 0, 0, 0, 3, 0, and 0, 0, 3. And I want to explode that tree. I've grafted it, so there's no real point to explode it. Interesting why I did that while I exploded it. Let me go back out. Got this vector, this vector, this vector. What happens when I actually flatten that data? I lose everything. So let me take that back to the graph. So that's the data I wanted. I'm not sure why it wasn't coming out looking like that. But those are my 3 coordinate vectors, and I've had the y going in an opposite direction, which is interesting to think about from point 0. Not too hard to figure out. Vector display down here, I can take the unit vectors, but I could also end up moving them from those points. Vector length is being told it's 9, and the length is coming out here as well. So you can find the vector length out of the vector from the vector length component, but then again, the cross product is giving you the vector length while you're finding the cross product. So pretty nice. So what have I done? I've taken these. If I take, this is what the example is. If I take these 2 vectors, this is kind of tricky. If I take this vector and I take this vector, then I will get a cross product vector that looks like that, which is pretty nice to think about. If I take this vector and I take, what are we doing here? No, if I take this first vector and I hit shift and take this vector, which is what I'm doing in this case, these 2 vectors, I'll get a cross product of that vector. So that's pretty nice to think about. And then if I take this vector and I take this vector, holding down shift, I get the cross product of what's going in here as that vector. So that's really where I'm trying to go. I think I had that right. This is the one I'm doing, and then this is the cross product to that. So you're starting to visualize what cross product really means. I've exploded the tree again, maybe because I changed my data structure. Let me flatten to kill it and graft it, and now I'm getting the proper data structure before it's simplified because there are more things happening to it. So it's following those paths, even though the first ones can be simplified and gotten rid of. I'm going to rotate the vector, rotate the vector, rotate the vector. And let's grab our visualizations, which are hard to do because we have not visualized these vectors. Reverse vector, reverse, and reverse. Let me grab this one, the anchor. Let me grab this vector. Let me grab this vector. And let me shift and collect this vector. And now we have visualization of these three different vectors, but I'm able to rotate them through, and you can see how they really dance as a unit to gain some control of what's happening. And I'm doing this through just a vector rotation. Vectator is a good word. Really nice pi to 2 pi to drive some geometries and have some nice mathematical control and visualization control over what you do. So jump into here. The angle over here is giving me the angle that's coming out when I'm ending up using it. Play around, get all of your stuff up and running. I'll update the cross product to the dot product. And where was my dot product? Where did I actually use it? Cross, cross, cross. Dot product was what I was playing with here. And the dot product is actually a number as opposed to a vector in itself to visualize. So you'll have to see that in the panel tool to see what's going on. So I hope that starts to build some visuals for getting a little deeper into vector mathematics. If you want to follow the work of Jose Luis Garcia, that's a good idea. And also Raya Isa has some essential maths that she puts out through Grasshopper and Rhino. Thanks very much for watching. I'm going to group it, and I'm going to set it back to the color that I've actually got my nose into here and started to follow. You know, mathematicians, engineers, physicists alike would probably be interested in how this actually gets data visualized as to what you actually need and you're looking for. 7.5 minutes.